Hello students, in today's session of NCERT chapter 6, that is system of particles in rotational motion, very basics on center of mass will be cleared through illustrations. In this session we are going to discuss what is center of mass. What is center of mass? Center of mass for two particle system. Center of mass for n particle system. When Newton's law is applicable for extended object. Center of mass. The distance of the center of mass. Distance of center of mass is inversely proportional to mass. All these topics are going to be discussed in this session, which will be very useful and helpful. Please go through the complete session. Now let's start with the concept and questions. Concept regarding center of mass. The center of mass of a body, that is system of particles, is the point which behaves as if all the mass of the body is concentrated there, where all of the mass is supposed to be concentrated. Second, if a force acts at center of mass, body will have translation motion, not rotational motion. Very important. Center of mass is a point about which the sum of moments of masses. Moments means mass into distance from reference point. Center of mass is a point about which the sum of moments of masses, that is multiple mass and its position vector with the expressium of all the particles is 0. Sum of moments is 0. Newton's second law of motion is applicable to point objects. To apply Newton's second law to extended objects, use concept of center of mass. Sometimes the center of mass does not fall anywhere on the object, or it may lie outside the body also. Example, center of mass of ring located at center where there is no any material. Further, center of mass of some well-known rigid bodies. What is rigid body? Rigid body is defined as system of particles in which distance between each pair of particles remains constant with respect to time, which means the shape and size do not change during the motion. That is a rigid body. Center of mass of uniform rectangular, geometrical center, and its center. These are the position of center of mass of a rectangular, uniform rectangular, square and circle plate. Next, this is the uniform circular ring, uniform semicircular ring, lies at h equal to 2r upon pi. Next, center of mass of a uniform semicircular disk with radius r lies at a distance h equal to 4r by 3 pi. 4r by 3 pi. Next, center of mass of a hemispherical shell of radius r lies at a distance of h equal to r by 2. This is the distance. Center of mass of solid hemisphere of radius r lies at a distance of h equal to 3r by 8. Right? These are rigid bodies and center of mass is given here. Right? Now let's start with the questions. Question is, two particles of masses 1 kg and 2 kg are located at x equal to 0 and x equal to 3. Find the position of their center of mass. Concept applicable in solution. This is origin. One is located at M1. That is 1 kg. One is located at x equal to 3. look, that is M2, that is 2 kg. This is a case of two particle system. Two particle system. As we have already discussed, position of center of mass is inversely proportional to the mass. That is R1 over R2 equal to M2 over M1. That is M1 R1 equal to M2 R2. These are the moments, right? Center of mass is closer. Center of mass is closer to the heavier mass. Center of mass is, these are the certain concepts that I have discussed. Now, as only along x-axis are particles, therefore x will be equal to m1 x1 plus m2 x2 divided by m1 plus m2, right? Here m1 is 1 kg and point is 0 0, and m2 is 2 kg, point is 3 0. Therefore substituting values, we get x equal to 1 into 0 plus m2. M2 is 2 into 3 divided by 1 plus 2. 6 divided by 3, that is 2. 2 centimeter. 2 centimeter. Means center of mass will be this one. 2 0. 2 0 is the center of mass. Now it is clear. Center of mass is closer to the heavier mass. Right? Next question. Question is, four particles of masses 1 kg, 2 kg, 3 kg and 4 kg are placed at the four vertices of a square of side 1 meter. Find the position center of mass of particles. X-axis, this is y-axis, this is origin. So one is square of this A, B, C, D. A, B, C, D. M1, 1 kg, M2, M3, M4, 2 kg, 3 kg, 4 kg. In this case, x1, y1, this will be 1 0. Sorry, 0 1. 0 1. 3.11. This will be 1. C point 1 0. D point 0 0. This is four particle system and two dimensions are being used. So center of mass will be XUM, YCM. We have to find this one. Now using a concept, XUM will be equal to M1 X1 plus M2 X2 plus M3 X3 plus M4 X4 divided by M1 plus M2 plus M3 plus M4. Right? M1 X1, 1 into 0 plus M2 2 into 1 plus M3 4 into 3 into 1 plus 4 into 0. I divided by 4, 1 plus 2 plus 3 plus 4. This comes out to be 2 plus 3 divided by 10. That is 5 by 10. That is 0.25 meter. This is axiom. YCM M1 Y1 plus M2 Y2 plus M3 Y3 plus M4 Y4 divided by M1 plus M2 plus M3 plus M4. M1 Y1, that comes out to be 1 into 1. 1 into 1 plus M2 Y2. M2 Y2 2 into 1 plus M3 Y3 0. 3 into plus 4 into 0 divided by 1 plus 2 plus 3 plus 4. 1 plus 2 divided by 10, that is 3 by 10, that is 0.3 meter. Right? Therefore, center mass of 4 particle system will be 0.5 meter, 0.3 meter. This is the answer. In the diagram, if you want to show it, so this is x-axis, this is y-axis, 0.5, 0.3, 0.50 or 0.3. This will be the center of mass. This will be center of mass. Right? Next question. Before start of the next question, I will request that for +1 students, +2 students, JEE aspirants and NEET aspirants and other entrance examination. These are the concept killing videos which will be very, very useful, which you can review on Statistics Learn. इसी के साथ साथ मैं रिक्वेस्ट करूंगा कि अगर अभी तक आपने YouTube चैनल Statistics Learn सब्सक्राइब नहीं किया, please subscribe it and share with your colleagues and friends. Now let's start with the next question. Find the position of center of mass of the uniform lamina shown in the figure. Concept applicable and solution. As we know, position of center of mass. M1 R1 plus M2 R2 plus over M1 plus M2. Now, if a body is one-dimensional, two-dimensional, three-dimensional, then we use L, we use area, we use volume. If object is made up of uniform linear charge density, surface charge density, volume charge density. Then, if it is one dimensional, we use x1, two-dimensional, x1, y1, xy, z for three-dimensional. Right? Now, it is a case of removal of mass. Then mass of initial circle, we will consider area. Area initial circle pi a square. Area of circle removed pi a by 2. This is a. So this would be a by 2. A by 2 whole square. Then pi by 4 a square. This is a1. This is a2. This is removed. We assume that it is made of uniform surface charge density. Right? Now, center of mass x will be equal to a1 x1 plus minus a2 x2 over a1 plus minus a2. Now, as plus sign is for added mass is added, or negative sign is for mass is removed. Mass is removed. Right? Then x will be equal to a1 x1 minus a2 x2 divided by a1 minus a2. Pi by 4 pi a square into x1. x1 will be 0 minus pi a square by 4 into a by 2. This will be a by 2. A by 2 divided by pi a square minus pi by 4 a square. This comes out to be on simplification minus a by 6, and y will be equal to, this is 0 0, this is a by 2 0, y is 0 0, y is 0. Therefore, center of mass will be equal to minus a by 6 0. That is the answer. If one minute I will review all the things. This is a general formula. If it is one dimensional, use x1, two dimensional x or y, three dimensional x, y, z. Now, if it is a continuous body distribution, then we can use to make the calculation simpler either length, area, or volume. Depending, provided condition is that they are made of uniform charge density, linear charge density, or volume charge density. Then we can replace mass by the length, or mass by the area, or mass by the volume. If things are added, plus sign. If things are removed, minus sign. Apply the formula, find the answer. Right? Now, I would like to request, if you are new to my YouTube channel, City Shift Learn, City Shift Learn, please like and subscribe to my channel and press bell icon to receive updates on concept killing videos. Thank you.